Kae.
Delta.
Discuss the nature of the roots. Alright.
So now I'm making the K and what? So
Eh.
take it out to see.
Alright. The nature of roots. Nature of roots of a quadratic equation. Now, it is important that we define what the roots are. Roots are values of a certain alphabet. That satisfies a given condition. Those are what the roots are. They are the values of a certain alphabet. They can say K or X or P, whatever, and that alphabet satisfies a particular condition that is provided. The roots mostly referred as the delta of a problem is defined by the mathematical equation the discriminant equals b squared minus 4ac. Let me include the square root here because we are interested on the value that is under the square root. This is what we are mostly interested on. What happens to the value of b squared minus 4ac? Where does this comes from? It comes from the quadratic equation f at x equals ax squared plus bx plus c, where we can say that the roots, which are the values of x, is equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. But we are only interested on the value that is under the square root, which is b squared minus 4ac, which is the delta or the discriminant of the equation. We can say that the delta which are the roots if the delta, the root of the equation, are greater or equals to 0, meaning they are positive, the value of b squared minus 4ac must be greater or equals to 0. This means that the roots are real and rational if the value under the square root is a perfect square. Therefore, the roots are real because any positive or any positive number that you get under the square root, that's a real number, irrespective of whether it is a fraction or not. Okay. But it is a perfect square if you find a value here that is a perfect square. For example, the square root of 4 is a perfect square because the square root of 4 is 2. 16, 25, 100, 0. The square root of 0 is 0. Therefore, 0 is a perfect square. Therefore, the roots are real and rational.
So, how come it be unequal or equal?
Right. The roots also, they can be real and irrational. In that case, the delta value, which is b squared minus 4ac, you get a value here that is not a perfect square. For example, you can find the square root of 2. The roots are real because the number is a real number, but the roots are irrational because 2 is not a perfect square. That's one example of roots that are real and irrational. We have the roots that are real and equal. That's where you will find, for example, let's say they are real, equal, and rational. For example, you can find x minus 2 squared. The roots are real, they are rational, and they are equal. Because here you're going to get two values here. X minus 2, remember this tells you to repeat this 2 times. So you're going to get x plus 2 2 times. So the roots are equal, they are real, and also rational, because any number that is squared is a perfect square. Be that as it may, we can have roots that are imaginary. That is when the discriminant is less than 0. So meaning the value under the square root, it's a negative number. This is just to wrap up the nature of the roots. But let's go to problems that might give us an idea of exactly what transpires here. Where are the exercises, Mo? Give me one exercise that we can do. X
squared minus 4x minus 5 is equal to
x squared minus 4x minus 5 equals 0. The question says,
discuss the nature of the roots without solving the equation.
Discuss the nature of the roots without solving the equation. Right. We will say, all right, the nature of the roots, which is the discriminant, is equals to b squared minus 4ac. We said we are interested on the value that is under the square root. You should be very cautious to understand that the coefficient of x squared is our a, the coefficient of x is our b, the coefficient, the number that doesn't have any alphabet, is our value of c. Right, we will take the value of b, which is negative 4, and we will try to square that. We will minus 4, the value of a is 1, and the value of c is minus 5. This will give you 16 plus 20, which is 36, and the square root of 36 is 6. So meaning the roots are real, rational because it is a perfect square, and unequal because you will get plus or minus 6. I don't know if we are fine. All right. Let's go to another. I don't know whether I should erase this side. Let's go to another problem. Give me another problem that might be tricky for you to solve.
Open bracket x minus 3.
X minus 3.
Close bracket. Open bracket x plus 2.
X plus 2
is equals to 5.
Is equals to 5. What does the question require?
The same question.
Discuss the nature of the roots without solving the equation. We are not going to solve the equation, but in order to find the value of a, b, and c, we need to write this in a standard form. So to remove the brackets by multiplication is the principle or the rule of Botmas. I will get x squared plus 2x minus 3x minus 6. Let me take it to the other side to get 0. I will have my x squared minus x minus 11 equals 0. Now that I have the value of a, the value of b, and the value of c, now I can say the discriminant equals b squared minus 4ac. My b is minus 1, a it's 1, c it's minus 11. I will get 1 plus 44, which is 45. So roots are real because this is a real number, irrational because it's not a perfect square, and unequal because I'm going to get two decimal places that are positive and negative. Let's go to another problem.
Yes. For which values of k will the equation x squared minus 5x minus k is equals to 0 have equal roots?
For which values of k will the equation x squared minus 5x minus k equals 0 have equal roots? So for equal roots, the discriminant must be equals to 0. So we say b squared minus 4ac must be equals to 0. I know this is my a, this is my b, that means that will be my c. Coefficient of x squared will always be your a, your coefficient of x will always be your b, and any other thing that is left becomes the value of c. My b, it's negative 5, that is squared. My a, it's 1, and my c is minus k, and this is equals to 0. Okay, I will say, all right, this is 25 plus 4k equals 0. 4k equals negative 25. K is equals 4, 8, 12, 16. It's going to give you a fraction. I don't know whether this is clear. Alright.
For the real roots?
For roots that are real. For the roots to be real, the value of k has to equals negative 25 over 4. For the roots to be real. Are we fine? Let's continue on your grade 11 journey of technical maths. Another problem.
For which values of k will the equation kx squared plus 2kx is equals to negative 3 have equal roots?
For which values of k will the equation kx squared plus 2kx equals minus 3 have equal roots? For equal roots, the discriminant must be equals to 0. So meaning b squared minus 4ac equals to 0. Now, let us try to check here. We need to write this in the correct way first. So I'm having kx squared plus 2kx plus 3 equals 0. Now, when I'm here, what is it that I'm going to do? I have a common factor somewhere here, which is k. Are we correct? K times x squared, kx squared, k times 2x, 2xk plus 3. Right. But now, there's a problem if I do this. How will I know the value of a, the value of b, and the value of c? So I should never factorize that. I should just leave it as it is. And I can say b squared minus 4ac equals to 0. My b will become 2k, that is squared, because that is the coefficient of x is 2k. That needs to be squared. Remember they said determine the values of k. Minus 4 into a, my a will be k, and my c will be 3, and this is equals to 0. Can you see I only have k here? So that means I'm correct in what I'm doing. So this is the same as 4k squared. I don't know if it is fine. I'm having minus 12k, that is equals to 0. I can either take this to this side, that's my choice, or I can take out the common factor. It really doesn't make any difference. But my advice would be take out a common factor, or you can divide everything first by 4. Divide everything by 4 because 4 goes into 12 without leaving any remainder. So that you can have k squared for a 12 minus 3k, that is equals to 0. Take out a common factor of k minus 3 equals to 0. So k equals 0 or k equals 3. I don't know if it is clear. So you will have equal roots when the value of k is 0 or when the value of k is 3. You will have equal roots. I don't know what answer you got here. Check for me the answer that you got.
It's correct.
It's correct. Let's go to another problem.
For which values of p will the equation x squared plus 2xp is equals to 9 minus 9p minus 4x have equal roots?
It seems like equality is their favoritism. But let's try to look into this. I'm trying to write this in a standard form. And then from there, this is what I have. And when I'm here, what is it that I can do here? For which values of p? So what I will do, by just looking into this, I have the value of a, that's fine. I have a problem with the value of b and the value of c. But this shouldn't be something difficult to solve. All I need to do here is to try and say, okay, let me take out a common factor here and see if it will work. The common factor will be p. I'll be left with 2x plus 9 plus 4x equals to 0. But this is highly problematic because now I cannot say this is the value of b. So this is not going to solve anything. So I can't go for this route. And then secondly, I check to say, all right, for which values of p? I know that the discriminant is equals to b squared minus 4ac, and this must be equals to 0. Now the question is, what is the value of b, and what is the value of a, and what is the value of c? So by looking into this, I can rewrite this as x squared plus 2xp plus 4x plus 9p equals to 0. And there's a common factor that I can take out here, which is 2x. And I can be left with p plus 2 plus 9p equals to 0. But does it solve anything? It still doesn't solve anything there. So what should we do exactly here? What is it that we should try to look at very carefully in here? What is it that we should try and look at very carefully in here? Lastly, I can say, okay, for which values of p? Look what is happening. I can take x squared and 4x. Can you see that? As the value of a, the value of b, and whatever that is left as the value of p. And I can now factorize this one. I have the value of A, I have the value of B, and this will represent the value of C. I can say x squared plus 4x. I have a common factor here of P. And I'll be left with 2x plus 9, that is equals to 0. I don't know if this is correct, but it seems to be correct, because if I take out a common factor of P here, I'll be left with 2x plus 9. So meaning I can say b squared minus 4ac equals to 0. What is the value of b? Because it is the coefficient of x. What is my a? And what is my c? They said determine the values of p. So it becomes p. You leave this, you leave it out, because you are looking for the values of p. It's a little bit tricky, this one. It has a little bit trick there. Remember, we are looking for the values of p. So you can't take this, you only take the value of p. And then you will get 16 minus 4p equals 0. 16 equals 4p. 4, 8, 12, 16. 4 equals p. Just go and verify for us what the answer is for this problem. It's 4, you see? So hence I'm saying it was a little bit tricky, this one. Please be careful here. We are looking for values of p, so you ignore the whole of this. You just ignore that. You are only taking out the value of p there. I don't know whether this is making sense. This one. What is happening here? This is how they have solved it. This is a very long route. This is a very, very long route. And now I would never go for something so long when I can see that there is something a little bit more. Because if we have to speak in terms of factorization here, unfortunately I can't. Or do you see this as complicated? So now I would honestly go for this one. I don't even use a memorandum as long as I have found the correct answer without taking the route, because if I have to look at the memorandum, that simply means I'm trying to copy what they have done, you see, and that's very problematic. I should be able to get what they have using my simple way of explaining. That means I understand the logic. So hence I'm saying to you, I wouldn't follow such a long route. I don't know that. But because we are getting the very same thing, I'm very confident that I'm doing things correct. Can we go for the last one?
Determine the values of p for which 3x squared plus 7x is equal to 2x plus p have non-real roots.
Non-real roots. We have spoken about that. We said the discriminant should be negative. So meaning b squared minus 4ac should be less than 0. But now we need to standardize this. 3x squared plus 7x minus 2x minus p equals to 0. Now I can rewrite this nicely because these are like terms. I can add or subtract. And then I can say b squared minus 4ac should be negative. My b it's 5, my a it's 3, and my c is minus p. And this should be negative. 5 squared it's 25. Negative by negative it's positive. This is 12p less than 0. Take to the other side. 12p less than negative 25. Divide by 12. P should be less than negative 25 over 12. 25 over 12. I don't know if this is clear. I don't know whether it is clear. Let me give you some time to copy that. They can give you a graph and they can say explain the nature of the roots. They can say explain the nature of the roots. They can give you in terms of a graphical representation. You must know when a basic problem is given as an equation, also graphically you should be able to reason and explain what transpires. But we will deal with that very soon. I think on the weekend we will get very deep into the previous question papers that deals with the nature of the roots together with a circle geometry. But I wanted to introduce the basics of this circle geometry so that you understand the underlying fundamentals that governs space and time. We have some problems here, and they are giving out the definitions of some theorems. You have a circular object. You have a line that passes through the circle, the center of a circle, which is what we call a diameter. And then if you try to join those two lines, if you try to join this line with this line, you will always produce an angle of 90 degrees. Line that passes from the center, which is a diameter, and you try to join those lines together at a vertex, they will always make an angle of 90 degrees. And we are saying these are angles of a semicircle. So they say here, the angle subtended at the circle by its diameter is a right angled. The angle subtended at the circle by a diameter is a right angled. We say that the angle in a semicircle equals 90 degrees. Acceptable reasons when stating these theorems, you just say angle in a semicircle. So meaning, we are therefore saying the golden rule here, if you have a line which is a diameter that passes, because a diameter is a line that passes through the center of the circle, or we can say that the diameter is twice the radius, because if you have a circle and you have a point from the center, you have a line from the circle to a point on the circumference, we define this as the radius. And if you extend this in this manner, you are producing what we call a diameter. And then if you construct a triangle in such a way that you try to join these two lines as one, they will always produce an angle of 90 degrees. And we are saying they are angles in a semicircle. Okay, that is fine. And then we can also try to look at the following. Theorem 3, which is a converse. O is the center of the circle. Calculate the size of the angles marked with small letters. Now suppose we have a problem here. And this is the construction that is provided. And you are told that this is center O, and this is alphabet A, and you are told that the angle here is 1/3. Now, the theorem here states that angles at the center are 2 times angles at the circumference. So, meaning the angle A will be 1/2 of angle 130 degrees. And then what is our reasoning there? We are saying angles at center are 2 times angles at the circumference. So meaning you will find your angle as is it 1 or what? 150 95? No. 130 divided by 2. 50 50 65. Is it 65?
65.
All right. Meaning our reasoning there Angles at the center are 2 times angles at the circumference. Okay, that is fine. That is fine. These problems will on. And then we have another one. We're having something like this. We have something like this. We have x, we have 95, this is the center O, and we have y here. And they say calculate the values of the unknown variables. O is the center in each case. So how do you think we will find x and y? How do you think we will find x and y? If we have a construction like this one, how do you think we will find angle x and y? To find angle x is very easy. We will say that angle x is 1/2 of 95 or of angle O. And then our reason would be angles at the center are 2 times angles at the circumference. So this will be 1/2 of 95, which will give us 45. Is it not 47.5? 95 divided by 2.
Mm, 47.5.
Right, and then from there, how will we find angle x?
Angle y.
Sorry, angle y. How will we find angle y? Because angle y must be a reflex. Now let me show you something. Are we fine? It has to be a reflex, because look what is happening. If the angle here is 95, the angle here is, this is a revolution. It's 360 minus 95. What's 360 minus 95? $95.
265.
So we can say reflex angle y must be equals to 1/2 of angle. Let's say maybe this one was O1. Let's say this one is O2. So the reflex angle y must be 1/2 of angle O. And reason is what? Reflex angle O2. It's a reflex angle, right? O2 in order to find y. But what is the reason? We are going to say again, angles at center are 2 times angles at the circumference, because this is an angle at the center, this is an angle at the circumference. So we're going to say 1/2 of 265, and then what value do we find? And then that will provide us with angle y. What value do you think we will find then? This must be 137.5.
132.5.
132.5 degrees. That will be the value of angle y. I don't know whether you did it. What value did you find?
Number one.
Problem number H. Problem number H.
It will say 120 degrees.
I'm going to pause. We did 360 minus 180 again. Sorry, 360 minus 95 equal to 265. Yes, this has to be a reflex of that. Rare 1/2 of 265 ki 132.5. Lona le fumane bokae?
120
What? 1?
120.
How did you find 120? Shabahan, the number H. Okay, na lagawa na ka mo ulit. Come on. Ake mo tsebe. Ake mo tsebe. E shebe hantle number H. O ebile o na le 60 degrees. Ngwane se na le pause. Ho na le pause. O ko e shebe hantle. Ke bokae? 132.5. Ne se ke tjho ke ra o na le pause le yentse. There's a serious mistake le yentseng mo. Right. Ke bone mo. Ke efeng ene o phazamisa mara mo?
Like mix understand the topic from
Hey.
the start, yeah.
Okay.
So Niki talk man, but most of the time Nick understands.
Oko ngetsetse this problem. O is the center. Ba o file 55. Ba o fa x. Ba batla o fumane the value of x. O is the center. In fact, POR is a diameter. Would you wanna find the value of x? Try to find the value of x.
Okay, number 1.
Let's see whether we will find the same answers. I know that if POR is a diameter, the angle that it will produce here is 90. So meaning angle x plus 90 plus 55 equals 180 degrees. Sum of angles of a triangle. Is it not 35? Somebody might say if POR is a diameter, therefore angle Q equals 90 degrees. Reason our angles in a semi-second. And then he proceeds to do this. Just to be on a safe side. Just to be on a safe side. You will start here first and then proceed to this. I don't know if this is clear. Suppose they say that we should find the alphabet X, Y, P, and Q. If this is the diagram that is provided. The first thing to note here is that you have what we call a tangent. A tangent is a line that touches the circle only at one point. And it? Right. If that's what a tangent is, meaning I have two tangents, and I was told that this tangent is equals to that tangent. If two tangents are equal, what do I know about two lines that are equal? If two lines are equal, two angles are equal. Reason being isosceles triangle. And it? So, I am told that this line is equals to this line, and I'm provided with a diameter that passes through the center of the circle. So if this angle is 60, therefore x is 60 degrees. I will say angle x equals 60 degrees, reason being equal tangents. Please, this is circle geometry, you must be very, very careful there. You cannot say isosceles triangle here. I don't know whether they will mark it correct or not, but I don't want to run through the risks. I want to do something that is correct. You're not going to say x equals 60 isosceles triangle, AB is equals to AC. No. Now I would start by saying this, but I'm not saying that you are wrong if you say angle x equals 60 degrees, and then you say reason AB is equals to AC. This is given, and therefore you can say comma and say another reason could be isosceles triangle. Now that I have x, I can find y. I can say y equals 180 minus 60 minus 60. Y, sum of the angles of a triangle. Angle y equals 60 degrees. Now that I have y, I know the angle here. It's 90 by construction, because this is a diameter. If this line meets with that line, they will always produce an angle of 90 degrees. Therefore, I can find the value of P, because I have x, I have this angle, and this forms a straight line. I can say angle P equals 180 minus angle x minus 35. Angle P equals 180 minus x minus 35. 180 minus, what is my x? 60 minus 35. What is 180 minus 60 minus 35? 85. I have my angle P. I can find Q the same way. Angle Q equals 180 minus 60 minus 36 degrees, reason being straight line angles. I don't know if this is clear. What is 180 minus 60 minus 35? That must 36. That must be 84. That must be 84 degrees. Are we fine? Line drawn from the center to the circumference if you have a line that is drawn from the center and it is perpendicular to the tangent, line drawn from the center perpendicular to a tangent will always produce an angle of 90 degrees. Are we fine? Okay. So, if we say to you, for example, by construction, prove that OA equals OB. Can you prove by construction that OA equals OB? I think we will deal with this on Saturday when we meet. We will try to prove that OA equals OB. Let me give you a chance to copy that. And that will bring us to the end of our lesson for today. There are more problems of circle geometry and some theorems that we will introduce. But for today, this was quite a mouthful for the day.